Welcome back to Murphy's Garage. Thanks for joining me, and please like and subscribe to my channel. Last time we finished up the steering and suspension. This time I'll show you what I did on the rock sliders and the front winch bumper. Rock sliders, we got rid of some rust and some dents and made it functional. The winch bumper, I won a winch at a drawing, so got to have something to put it on. Both of those things are done pretty much out of scrap metal I had around here at the shop, so I'm kind of into work with what you've got and make it look nice and functional more than anything. The second thing we're going to start on today is the engine conversion that I did on this Cherokee. To start that, I got a hold of this beauty 2007 work truck with 325,000 miles on it, and I got it pretty cheap. I could use the truck, so I'm going to keep the truck, and the plan is it's got an old engine that has oil pressure issues, so I'm going to do several tests to determine why it has low oil pressure. Hopefully it's something easy, and then I can just slap the engine into the Cherokee and limit the amount of tear down and rebuild type stuff I have to do. Well, good news, bad news on the engine. I ran some tests. I've determined that the oil pump is good. I don't have to worry about that. I ran a mechanical oil pressure test at the port that's up by the front of the engine before it goes through all of the oil galleys. The second thing I did is I put in a known good oil sending unit to make sure that I was getting an accurate reading out of the sending unit, both of which checked out okay. So my next step is to pull the oil pan, check the O-ring on the pickup tube, find out if that's any good, and then if that's good, start tearing it down and go from there. This is the 6-liter I got from the salvage company. It's got 125,000 miles on it. You can see it is complete top to bottom. It also has all the front structure and drive pulleys, which I'm going to need for the Cherokee conversion. It took me a weekend to swap that engine out of that work truck, and so that one's ready to go. I did all the tests as I mentioned. Now I'm looking at things inside the engine. Once I pulled the pan off, I was able to check the pickup tube. The O-ring's fine. There's no indication of anything leaking. I can run some air pressure in the tube and I don't get anything fizzing out of that O-ring. So I think it's probably further deep in the engine than that. As I take everything apart on this engine, I clean it, inspect it, and I put it in order and set it where I know where it is per cylinder on the bench. That way, as I'm inspecting things, when I find a problem, I can identify it and I can also backtrack it on every other component in that particular cylinder. I wanted to point out a couple things with this engine upside down. You can see the 4 main bolts coming out of each cap. There's also a bolt going in each side of the cap from outside the block. That makes these 6-bolt mains. The other thing is the position of the crankshaft is inside the block, as well as the bearing caps are recessed inside the block. From my machine shop training 30 years ago, that would make this a Y block, not a V block, but the position of the crank and the bearing caps is what makes the bottom end of these so strong, especially when you start throwing superchargers and turbos on them. You really don't have any problems with crank deflection. You also want to have a set of stamps so that you can properly number every main cap so it goes back to its original position and location. You also want to number every rod and rod cap. These rods are machined, drilled, and then they break them. So each rod cap requires to go back to its original rod. You cannot mix them up or it'll really destroy this engine fast. It's a real important thing to put all this back in its original location. You can see that circle cam bearing below the crankshaft journal. That's where the cam slides in. Those bearings are completely worn out, way beyond specs. That's where my oil pressure is going. That's the culprit, and so now we're going to have to get cam bearings. Once I had everything apart, I measured the crankshaft journals. I also measured the cylinder bore and determined the only thing I needed done on this block was honing. So I took the engine block down to the machine shop. They boiled it. He honed it for me, and then I had him press in the cam bearings while he had it all apart. He's got the correct tools to do that, whereas I don't. With the engine block down at the machine shop, I took the time to clean up the rest of my stuff in this engine, painted it up, and got it ready for reassembly. Just a reference on these video clips I'm using today, they are from Coyote Canyon out in Moab. I was invited on this trip a few weeks ago. We had a pretty good time. While I was waiting for stuff to get back from the machine shop, I decided to get rid of the old dented and rotting rockers on this thing. So I cut them out, and then I welded in a piece of 2x4-inch rectangular tube. It's 8 to 1/8 inch thick, and then I added a piece of 2x3 3/16 angle iron to the bottom of it, which gave it a profile and a whole bunch of strength. The next thing I did on these sliders is I built a step, just like I did on the rear bumper. I used square tube, and then I welded a plate on the top, and I added spot welds to act as grip tape. I did want you to notice this tab here. I didn't want to weld the front fenders into this rock slider. This is all part of the body, so it made sense to weld these directly in, and they're structured and welded on the backside. This tab is welded to the slider, and then I trimmed the fender and bolted it in. That way the fender is still removable. Here's how the rock sliders finally came out. You can see they've got a little bit of a profile because of that angle iron on the bottom welded in. Welding these tubes to sheet metal gets a little tricky. They like to burn through and warp pretty easy, but got it handled. Here's the back side of the rock sliders. You can see where it's welded into those old hat metal for the body structure. I did not seal this area under here. There's some spot welds occasionally, but it's painted real well, it's coated real well, and I want water to be able to drain out. You can also see you get some profile by using the angle iron on the bottom of the tube. Since the machine shop was backed up for a few weeks, I took the opportunity to go ahead and build my front bumper and winch assembly, which is pretty much built out of all scraps that I had laying around the shop. So here's where I started. So I took that old winch plate that came with this Jeep, cut it up so that it would fit the way I would want it. I added a bunch of structure both on top and underneath. Once I had everything spot welded, I burned it in, welded all the center section up, including underneath, where you can see here, these angle tabs are welded into the side structure and they go back into the frame. I added these extension tubes from the leftover material on the rock sliders. They go out to the edge of the fender. And once those were welded in, I added some pieces of square tube and stacked them up to fill in that area behind the marker light, which you'll be able to see in the finished video. After that, I pulled the bumper off. I added some reinforcement to the bottom of those extensions. I added the tow hooks to it, and I added some skid plates to the bottom. Then I fully welded it, sanded it down a little bit, painted it, and got it ready to install. Here's what the bumper looks like installed, and I wanted to point out those tubes I welded to the outside to fill in that gap behind the marker light and that fender area. Came out pretty good. It kind of makes it flow into the fender a little better. And here's what it looks like with the winch installed on it. The outside of this winch tray had quite a bit of extra space, and I figured out a good use for it. An ARB air compressor mounted absolutely perfect in that space. I built this cover plate for the ARB compressor. You can see the one brace tab on the one side, and then it's got the two nuts that mount to the winch tray. After it was painted and installed, you can see it gives a lot of protection. I can get to my air fitting. It breathes well. I think this works better than having one under the hood. All right, so in building this bumper, you can see I've got this big tab here that comes back to the cross member. That is a secondary bumper support, plus I've got all this triangulation tab built up. This bumper will not come off. It is extremely tough. While I was doing this, I repurposed the old shackle mount to help support the steering box skid plate. So got a little protection on the front of the steering box at the same time. I wanted to do kind of a final walk around on this. The bumper sits really nice. It's sucked up pretty close to the body. All the bolts lined back up after I got done welding it and putting it back together. I did want to take a minute and show you the side of this superstructure where it comes back into the frame. It's welded and bolted into the frame. And then up front you can see there's multiple bolts that go in and kind of triangulate everything together. I did weld the old holes back up on those tow hooks when I welded them in, so they look a little cleaner. The tray is a little bit bigger than what I needed, but it actually turned out pretty good with that ARB compressor fitting into one side. I like my splat man there. He kind of finished it off. I also can get to the air fitting, and I did cap the air fitting with a piece of a rubber boot so dirt won't get in there. I added the LED lights when I rewired this at the time of doing the engine swap. You can also see I did the infamous spot welds, so I have something to stand on if I'm working on the engine. And here's those 3 square tubes I welded up to cover that gap, and I actually kind of grew on me. It allows the bumper to really flow into the fender, kind of ties it all together. The last thing I decided to do while I was waiting for the engine parts to get back was get rid of these rubber fender flares. I didn't mind the flares, but whoever cut the fenders cut them up too high, and there was a big gap between the fender and the inner fender well, causing a problem with rust, which is the enemy here. So I cleaned it up, and I used a piece of 3" by 8" flat steel that I hand formed around the fender well opening, and then started welding it in. I got it a little overzealous on a couple places and warped some of the sheet metal, but it is welded in both the inner and the outer fender. Once I was done, I knocked the high spots off the welds, and since I don't have any orange paint laying around that's 50 years old, I just painted another black stripe on it and called it good. Yay, the engine came back from the machine shop. I cleaned it again just to make sure there were no metal filings left in it. I also double checked the cam bearings, made sure they were pressed in all the way, and got the block ready to reassemble. New main bearings and the caps installed. The crank is installed. I have a good rotating assembly. I then installed the pistons to the rods and then installed those to the block with the new bearings, rod caps, and they are all torqued to spec. I wanted to point out this piston ring compressor. I really like these compared to the old style. This is actually funnel shaped. The bottom side sits right on the block deck. It's got a small expansion joint in it that you just squeeze down. And when you push the piston rings in it, it compresses the rings, slides them right in the block. It's probably the easiest style I've ever used. This one is specifically for like the 6-liter, and then I've also got another one for the 4.8 and the 5.3s. This is now an LQ9 and not an LQ4, since you can now see it has a flat top piston instead of the dish piston. This gives me a significant bump in compression, which normally aspirated means more power. Next is the timing chain, timing gears assembly, along with the oil pump. When you install these timing chains, make sure you dip them in oil. That way they have good lubrication and you avoid any wear damage on your initial startup. I also prime these oil pumps before I install them and after the engine's together. Next is the timing cover and the harmonic balancer along with the front main seal. Now I do install the oil pan without a gasket on it to act as a guide plate when I install this. That way I don't have to have an alignment tool. The rear main seal, you want to leave that piece of plastic in the main seal when you install it to the rear of the engine. It acts as a guide and gets it over the crankshaft. Once you are over the crankshaft, you can hand install all the bolts to the cover. The oil pan is still in place with no gaskets so that you don't have to use a special alignment tool to keep everything in place while you get all the bolts torqued. Once all the bolts are torqued, then you can remove the oil pan and continue on the rest of the assembly. You can see the camshaft with all the assembly lube on it. I then also take all the lifters and soak them in oil, make sure I get all the air out of those and install them. With the lifters installed, I install these retainers on top of the lifters. I also pour oil down inside of these retainers to ensure I have plenty of lubrication as this engine's going together. I got the heads back from the machine shop, did a valve job, replaced the valve guides, valve seals. The springs were in good shape. I did have him also mill 30,000ths off of these heads, which between that and the flat top pistons gives me a pretty good compression bump. This thing ought to run pretty darn good even without a turbo or a supercharger. Just a reminder, use good head gaskets and new head bolts every time. These are torque and yield bolts. You cannot use them twice. I did go with a set of OBX headers. They have a really nice good sealing flange on them. I don't think they're really going to flow any better than the original manifolds, but what I'm using them for is to get the heat out of the cylinder head faster. Anytime you can lower the heat in a cylinder head, you'll have better performance. After I have the long block assembled, I finish assembling all the accessories I can to the engine to make sure I don't have any fitment issues. The other thing I do is I prime the oil system with a gauge on it. I make sure I have good oil pressure before I install the engine to the vehicle. Once it's installed, a lot of these things become a lot harder to fix. It's a lot easier to do it while it's out and take care of a problem ahead of time. It dawned on me when I was finishing this part of the video up that instead of just doing an oil pressure repair and sticking it in this Cherokee and doing an engine conversion with a stock LQ4, because of where the oil pressure problem was, I ended up having to tear the whole block down. Which meant at that point, you may as well rebuild the whole thing. So when I got to that point, I did decide to go ahead with an improved piston combination, being flat tops, which brought it to an LQ9. I did put a little bit different cam in it. It's an LQ9 cam, but it's just a little bit more on the performance end. Just not, it's still mild, so I wouldn't say it's a hot rod cam or anything like that. The milling the heads also bumped the compression a little bit. And then one of the things I did that's probably one of the best things I did was I had a pretty hot tune put into the computer. Legitimately, this is a 4 1/4 horse at the flywheel engine. Some of the articles I've read said would most likely be closer to 500, but I also know horsepower ratings are generally overrated, not true ratings. But with all that being said, if you're comfortable doing this kind of engine work, that's fine. If you're not, you can always pull the engine out and just take it to a good machine shop, and they'll advise you what's wrong. They'll also kind of guide you in performance modifications. However, I will give a big word of caution. It's real easy to get caught up in that can of worms. These LSs are really nice with turbos and superchargers on them. I personally prefer superchargers, but that's another story. And you can get away with a lot of horsepower on these, but I also decided to look at what I'm using this Cherokee for. I want to be able to drive it 200-300 miles if I want to a trail, four-wheel it all day long, not worry about breaking anything, and drive it home, which is kind of the reason I went with the 1-ton axles and some overkill on the suspension and drivetrain. So that being said, that was my determination in not putting a turbo or a supercharger on. Superchargers and turbos, as reliable and as fun as they are, there are more moving parts, more things to break, more things to worry about. The other side effect when you start running additional boost is temperature. It creates heat. Another downside for me is it reduces the longevity of an engine too. I think this thing will go another 300,000 miles before it needs a rebuild. So that was kind of my justification. But if you've done a lot of engines, you're comfortable with whatever you want to do, you know, build as much performance as you're willing to pay for, I guess. And if you're not comfortable doing engines and you still want the performance and horsepower, it's available out there and it's pretty easy to learn. I always encourage people, if you want to learn something, get out of your comfort zone and jump in it. Me, for instance, I am out of my comfort zone doing these videos, but they're fun and I'm getting better at it, I hope. Other than that, next time I will do the engine installation. I've got a 4L80E I'm going to do some inspections on and get it ready to install with the engine. And then, as most 50-year-old vehicles are, they look like a rat's nest under the dash and where people have spliced in a bunch of wiring. So I gutted all the wiring on this and started over, since I have a nice new engine harness to integrate into that as well. So I appreciate you watching. Like and subscribe to my channel, and I'll see you on the next video. Thank you.